Good afternoon, everyone, and welcome back to the Blue Stage, well, where it's time to once again create a kind of informal and personal atmosphere. So that means the next fireside chat is coming up. We have a couple of brilliant experts on stage in a minute, but of course, first of all, we want to welcome the moderator of the next session, and I'd like you to give her a big hand. Please welcome Doro Gelmer.
Thanks, Tobias. Hello, everyone. Everyone in a good mood? Yes. Well done. We want to focus on mobile EV. My name is Dorothy Gelmar, and we have a great fireside chat now. You can see it already behind me. Further, longer, saver. These are not only some keywords or words that sound good. No, we believe in that. We think that these words and the new technology that we want to talk about in the next 45 minutes have the potential to be a game changer in the industry. In the next 45 minutes, we want to focus on the new generation of EV fluids. We want to give you insights, we want to give you information, and we have a best case collaboration that we want to share with you. A collaboration with Porsche. We want to talk about the Porsche GT4e performance. So exciting, stay here. We also have some seats in first row, and for sure, I'm not the only person, I'm only the lady with the questions the experts have to follow. Please give it up for Berus and Tobias from Mobile EV. Hello, guys. So, make yourself comfortable.
Thank you.
Thanks for being here. We have 45 minutes that we want to focus on the new generation of EV fluids. And I know that your heart beats for motorsports, for cars, and for the technology behind that. Maybe you want to give us a bit more details about your CV.
Yeah, thank you, Doro, for the introduction. My name is Tobias Klande, and I have a PhD in chemistry and joined ExxonMobil in 2014 in Hamburg. First started as a Mobil 1 engine oil developer, but then had several projects and also assignments. And since 2019, I'm actually working in the EV and driveline space as a formulator in the team in Hamburg. And in one assignment and project I have is actually that I'm leading the global Porsche motorsports projects. It is LMDH development, Formula E development, and especially the GT4e performance, which we talk about today.
Thank you, Tobias. Berush.
Yes, my name is Bero Sangeta. I'm an automotive engineer, so we complement each other with the mechanical engineering and the chemistry behind it.
Perfect team.
And I started in the automotive lubricants industry since 2009, before with another oil company, and now since 2016 with ExxonMobil. And I take care of the Porsche series development work for the electrification projects, EV and driveline.
Berus, thank you for being here. EV fluids, an interesting topic we want to focus now, and they offer so many advantages, right?
Correct, they do, and we're going to make a deep dive today into thermal management fluids, show you some interesting test results which prove the performance of our mobile EV products, and last but not least, we're going to invite our colleague from Porsche and talk about the GT4e performance on stage here.
Perfect. We see it already on the street. Mobility is changing. How do you, Tobias, personally see the future of mobility?
Yeah, I guess we don't have a crystal ball, let's say. Right? It's clear.
We should. Everyone wants it.
But we see that the landscape is changing. We also see that, at ExxonMobil, we see that we see the future of mobility as a mix of internal combustion engines, but also electric vehicles and other different alternative powertrains. And actually, we are committed to lead across all of these energy types. And we see it here in IAA Mobility, but also discussions around the world, that EVs will be a daily reality, also in the auto and trucking industries. And in fact, some countries even think about banning banning internal combustion engines and transition to electric, which makes them more like a daily reality rather than the exception in the future. And actually predicts that by 2050, roughly 35% of the passenger vehicle car fleet will be fully electric. And at ExxonMobil, we have a long and rich heritage over around 135 years in leading in the energy technology, but also in innovation. And when we want to support and contribute to the transition from the internal combustion engines to the electric vehicles. And with our EV technology and expertise in equipment manufacturing, we can actually help electric vehicle, but also component manufacturers to improve the performance, but also the efficiency in their future mobility solutions.
When we talk about technical challenges, I'm sure there are everywhere. Which technical challenges come in your mind when you think about EV fluids, Berus?
Yes, so when we talk about battery electric vehicles, so the first question we always get, there is no engine oil in it, so what is your role in helping out to develop products for this vehicle?
Yeah.
So as we know it, we don't have an internal combustion engine in it, but we have powertrain systems, we have axles, we have bearings which need greases, and therefore we are here to support the new technology and advance it in terms of the lubricant business. So we are able to, if you look at the words further, safer, longer, it's not just a fancy marketing word, because if you look behind it, the further is translating into efficiency. We need to provide products which deliver efficiency and sustained performance, so you can drive longer. So that's the word further. So we need the efficiency in order to drive further with one battery charge, for example. Then there is the word longer, which translates into durability. You can use your equipment, your vehicle, for a longer time, because the products we develop help the systems to work durable and don't break down over the lifetime of the vehicle. So we cannot go into details. We can talk at the booth if you want, but there's a lot of things to talk about this. And saver, last but not least, is one of the key priorities, especially currently strongly in the media, is battery safety and burning cars here and there. So we are targeting to provide safety or extended safety to the battery systems of these vehicles, because with our fluids we are able to mitigate the risk of such battery fires so that there is no catastrophic event, and so we can keep it safe. And that's what it is all about it.
3 words that we all will connect to mobile EV in the future.
Correct.
Further, longer, saver. And when there are challenges, I'm sure there is a solution. And I'm also sure that our guests here want more details. Berus, we want solutions.
We want solutions. Ist das deine Frage?
No, it's yours.
It's mine.
Yeah.
So, yeah, basically, this. Are you seeing this slide? Yeah, this slide is exactly what I said. So we, when we talk about these solutions, we have to compare it to the conventional lubricant business. So with EVs, we do have the conventional lubrication part and regime, but we have now added constraints or challenges, which are the electrification part. So we have to develop products which are able to work with electrified systems, be compatible with copper corrosion properties, electrical properties, and also with higher temperatures in terms of the cooling fluids we are working on. So that is the key we are addressing with this triangle of the slide you see there. So some new items are added where others are not needed from the conventional lubrication business we have known so far.
Okay. Tobias, could you share some details, or maybe many details, of the latest innovations?
I guess, and just connecting what Bruce just said, in EVs we still require traditional lubrication properties. So we have still viscosity to have sufficient film thickness. We still have, we want to reduce the friction, that we have more efficiency gains. We have additives for wear protection and also oxidative stability. But we will add, as Bruce also said, we have to add new fields like electrical properties, conductivity, resistivity is a problem. Also new materials which get into contact with oils which haven't been in contact with oils before in the traditional lubrication space. But one crucial point really is the thermal properties of the fluids we are going to show you later. And actually the thermal management system in EVs plays a huge role to actually determine the range, robustness, but also the reliability of these cars in the future. For example, takes a battery. Battery wants to be at an optimum temperature to operate safely and performance-wise. And typically this is around, depending obviously on the battery, but you want to capture in a range between 20 and 40 degrees C for safe operation, longer battery life, and also performance. And how we do it today, there are two options, either air cooling or even water glycol. Mixtures, or ethylene glycol mixtures, which is commonly known as antifreeze, and this is basically typically pumped into cold plates, which are typically below the batteries. So it's not the most efficient way because you're not in close contact, it's indirect. And what we're showing here today, our dielectric fluid can actually help here because we can go where the heat is, where the temperatures are, and actually reduce them. And I guess we have a video showing.
Yes, we have a video exactly for that. In a second, now we see the different kinds of cooling, non-immersive cooling, and this is the mobile EV direct immersive cooling. Can you share any result with us?
I guess
you need to click once
the video
more.
just stopped. Okay.
Okay.
Yeah, obviously we are always looking to improve the thermal management system and our solutions we're offering, trying to look outside of the box. That we are trying to go away from the standard route everybody is doing. So, for example, reducing the viscosity is a big lever to actually improve the performance. And in this case, what we actually do is really, trying to design it in a way that the lubricant or the thermal fluid can go to the heat sources in the batteries, in the power electronics, and also in the electric motors. And obviously for that we do simulations, we do testing to prove that this concept actually works. But what is better than a real proof of performance we show you later.
Yeah.
So that's why we do the pre-work, but also we need partners to show the hardware actually in the street on the racetrack.
And ladies and gentlemen, pictures say more than 1,000 words. We have a video prepared for you where you can see exactly that, and maybe you can tell us what we see there.
This is typically when you do abuse testing of the batteries to see what is the impact if a battery has a malfunction or there's an accident. And you can see it here on the left side. It's a video where you have immersion in a liquid we have developed. And here now you see what happens when you don't have a liquid that prevents the safety testing.
Okay.
So you see that the nail is penetrating, the batteries on the top instantaneously go into a thermal event. You have the spreading to the neighboring cells, and after some minutes, you can see it in the video, all of the other cells in a kind of cascade will explode as well.
That's what we don't want to see.
That's what we don't want to see, and we want to prevent this. And you will see now the whole battery pack, 9 cells in this, cylindrical cells is in this video, but everything is completely burned.
And this was only a test, so relax, everyone.
And now you see the same test setup where we actually have these 9 cells immersed in our developed fluid. This is a mobile EV Therm Elite 701. And let's look at the difference. What happens? The temperature still, you see the penetrated cell increase very much. Also neighboring cells increase in temperature. You see a lot of smoke, but no fire actually, which is good. And you also see that after 1.5 minutes, 2 minutes, all the temperatures will be drastically reduced. So there's no thermal propagation. All the batteries have uniform temperature. That actually shows the potential of this, this technology. What we can say is this was a simple test. But there are a lot of companies coming up with new tests. You don't use only heating pads. You use also nail penetration. You also use heating pads. You can overcharge the battery. So there a lot of different tests you can do, and the temperature challenge we can solve with our direct immersion cooling.
So we have seen the battery abuse test now. Are there some other tests that you can share with us about safety, for example?
Absolutely. I mean, what we just saw was a very rudimentary test setup. So we took 9 cells connected to each other and put them in a test like this with the nail penetration. But after you have visited our stand, you can also go to the colleagues of Sing Mobility. We have worked with them also on an actual production unit, which is a fully immersed battery system with hydraulic system, with heat exchangers. And there, the fluid, we have tested our fluids with this unit, where it is a direct cell-to-coolant contact. And in this abuse testing, we have also passed the test by Sing Mobility that our fluids can actually mitigate the risk, or it doesn't allow for a catastrophic event. So the neighboring cells, for example, even if the cell has exploded and it was hot around 280 degrees Celsius, it didn't propagate to the other cells. And that's why this is a very interesting proof of performance or proof of concept, which is not only on the lab scale where we have a lot of fluid around the cells with like in the first test, but an actual production unit which proved to be working with this technology. And it's not only about batteries. It's the electric motors which we will become on stream or which are on the market right now. They also get very hot. So right now there is a different cooling strategy with water glycol indirect, as Tobias said. So the water glycol is obviously not in contact with the electrical circuits, which would not work. So the next generations are probably going to be directly cooled too. So the windings, the power inverters, the electronics will be in direct contact with the cooling fluids, for example, we have developed. And with this combination, you can also take away the heat directly and keep the systems working at a feel-good temperature over the lifetime. And we all know that temperature has a very adverse effect. If it's running too hot, the durability suffers. So with this, we can always control the temperature and be in a very moderate temperature range, depending obviously on our partners doing the hardware, developing the hardware. It's a hand-in-hand collaboration to find an optimal sweet spot here.
That sounds great. I am already convinced, but I'm sure you have some more gains to tell, to share with us, Beruz.
Yes, I can. This time I'm going to jump into the EV transmission fluid development space. What you see here is, for example, a full production VW ID4 vehicle, which has been, which we have tested and conducted proof of performance testing with our external partner labs. In this case, it's ISP, where we worked with. We put it on the chassis dynamometer, and what you see here on the bar chart is, on the left side, you see our novel PAO, which we have commercialized in the market. And all these fluids, all these 4 bars, they represent the first 3 bars represent same viscosity level, same formulation and additive chemistry. Just the base oil is a novel base oil from us, and we could squeeze out more range, so we could be more efficient with a transmission fluid like this compared to formulations using conventional synthetic products, semi-synthetic products like Group 3 and Group 3+. On the right side, you see even a further reduction in viscosity with novel PAOs, which we have been using. And for this vehicle, with this setup, and obviously also some calibration and back-to-back testing, we have been able to even squeeze out a little bit more efficiency. And I strongly believe that we can even squeeze out more of this gains when both parties, engineering partners and OEMs and suppliers, work hand in hand in a co-engineering approach to deliver even more efficiency. So that is still some options we have to go further.
Working hand in hand is always the best, and we have a perfect example in some minutes for exactly that. When I hear you talking about these tests and when I see the pictures and so, I think it's on the one hand a lot of fun and it's exciting, but what I'm interested in, what about the technology? Can we already find it on the street?
Yes and no. It depends on what stage we are, on which customers we are talking about. But for example, with the collaboration, close collaboration with our colleagues from Porsche, we have been able to track-proof our products and lubricants and cooling fluids and bring them from lab, from track to the streets. And these are projects which we are currently working on, and they will come on stream anytime soon. So definitely.
So how is that working when you transfer in the lab and on the racetrack to bring all to production?
So for example, for the transmission fluid, in electric vehicles, the transmission fluid is still a key differentiator. These electric vehicles, they have very demanding requirements to the lubricant, and operating conditions are pretty demanding. We have high torque, high RPMs, and efficiency plays a key role where we can play out this benefits. And we have shown this with Porsche, for example, that they can compete and win competitions by squeezing the last drop of efficiency out of the system.
So, ladies and gentlemen, we heard it. Mobile EV produced a new product for all electric racing, the advanced 3-in-1 thermal management fluid, which was developed, which was engineered for Porsche GT4e performance. In the last minutes, we got some information about the technology behind that. And now we want to give you the insights from Porsche itself. And for that, I'd like to welcome a gentleman on stage who has race blood in his veins. He is part of the Porsche Motorsport team since 2012. He and his team have developed the LMP1 919 hybrid high voltage battery system, which is a direct cooling technology which is used here. And the team had many reasons to celebrate and to be happy. Talk about the 3 Le Mans victories, the overall Nürburgring record, just to name some. Since 2019, he has worked on the battery system development for the Mission R and the 718 GT4e Performance. And currently, he is in the role of Team Lead Energy System. Welcome on stage, and please give it up for Rüdiger Clotinus. Hello, Rüdiger. Good to have you here.
Hello.
And the pictures that we see, I got goosebumps when I see that. I think that happens to someone else in the crowd too. We see the Lausitzring here and the GT4e Performance in action. So again, Rüdiger, thanks for being here. I just mentioned motorsports, it's in your veins, it's something that your heart beats for, and we saw the GT4e Performance already. I hope you brought some time because we want all information about the car. So just one question, what is it? What is special about the GT4e Performance?
Yeah, so for me, it's as well the same situations. I like always to see the car on the racetrack because it was made for this, and I get some goosebumps seeing that nice pictures. Yeah. And I'm lucky to be often on the racetrack with the car as well, so as a high voltage engineer. But what is it? We have shown the Mission R 2 years ago here in Munich on the IAA Mobility 2021. And the Mission R is our vision of a fully electric GT race car for customer racing. And the GT4e Performance, it's, let's say, the next step. So it carries all of the technologies, lots of components from the Mission R, now ready for the racetrack, for the World Demo Tour, which we are running at the moment. So we show the car all around the world, and it's really without any limits running. So that means we have the 4-wheel driven car, we have a power performance of up to 400 kilowatt in the race mode, and with that we are able to do the lap times of the GT3 Cup car for a duration of roughly 30 minutes, so which is a typical race duration of a Carrera Cup race. But if the driver is not excited yet, we can go one click further on the steering wheel and go to what we call the qualification mode, and then the car can release up to 800 kilowatts. So in old numbers, it's 1,088 horsepower, and that for a Cayman. Yeah? So both of the cars are based on the proven GT4 Clubsport chassis, but for sure with brand new technology inside.
I can see everyone smiling here in the crowd when you talk about that, Rüdiger. In the first part of our talk here on stage, we talked about EV fluids. Where is the link from the EV fluids to the GT4e Performance of Porsche?
So that is, we have a long-term partnership and a really, really good and close cooperation with ExxonMobil. So we are working closely together. We developed, for sure, the components and a very innovative cooling system with directly oil-cooled e-motors, with a directly oil-cooled battery, which is actually my baby. And for sure, we are collaborating on the cooling fluids, on the lubricants as well, with the Mobil brand. And this cooling system, let's say, is for us, is the key. It's really the key for the performance that we can deliver, because due to that, we are not limited thermally, so we can go flat out with race performance from the start until the end of the race.
Let's dive deeper. Let's have a closer look, Tobias, into the system. Can you give us some information about the thermal management system inside?
Yeah, for sure. I mean, before we start deep diving, as you said, let's come back to traditional lubrication. So in this electric vehicle cars, we still have a gearbox fluid to actually lubricate the rear and front axle. And also we have greases. But as I mentioned before, there's a new exciting field of application. It's the thermal management system. And what we want to show here, actually the silver bullet is that we combine one oil circuit for the battery, the electric motor, and even the power electronics. And we, as Rüdiger said, have to develop this fluid together with Porsche in a close collaboration. And let me show you now how it works in more details. So, as you can see here in the front of the car, you have a heat exchanger to actually release the heat to the environment. You then go from the heat exchanger to the batteries. You have 3 battery modules distributed in the car for even weight distribution. And you go directly in the batteries, and that ensures that they always have the sweet temperature, sweet spots they want to have. Also, it helps to enable the quick charging capability, which is also very important because you don't lose so much time to recharge the car. And also, it can help to increase the battery life. When we go from the batteries, we go directly into the rear and front axle. We have an electric motor and an inverter on each of the axles. And the inverter, as you may know, is responsible for actually translating the direct current from the battery into alternating current, that the e-motor can use it. And these electronic components like to operate at lower temperatures for more efficiency. Also, it helps to kind of prevent thermal degradation and aging of this componentry. And then, last but not least, you go in the electric machine directly on the copper windings where the heat is generating, where the highest temperatures occur. And this helps you to prevent the thermal derating. So let's be clear, in this car, there's no thermal derating at any time. You can go full speed until the battery is empty. And one point I just want to add to you, Rüdiger, you always have a lot of recuperation in this car as well. I guess with over 600 kilowatts, right? So again, always 600 kilowatts recuperation in this car.
Yeah, that's true. So we limit the acceleration power in the race mode to have the energy content fulfilling the race duration, but the recuperation is just limited by the cell chemistry, so by the battery cells itself, and it's not limited by thermal events.
Yeah. And then we go back from the e-machine directly into the heat exchanger in the front, and then start over the cycle again. And roughly to say, you have 30 liters of thermal management fluid in this car, and we pump it around twice every minute. So it's at high speed pumping.
Wow.
And this really ensures that you can go directly on the components where the heat is. You don't have limitations for thermal derating and no safety concerns. And the performance, I guess we have watched the videos, is pretty clear, and it's a lot of fun to watch it and to drive it.
On the Porsche point of view, Rüdiger, what are the advantages? Why is oil cooling better than the existing options?
I think Toby and Birus mentioned the major points. So due to the dielectric cooling fluid, we are able to go directly to the heat source and get the heat out of it. So we have really, really low thermal resistances. And therefore, we prevent the system of overheating. And this is important, especially for a race car, because you're always on full throttle, that is clear, but we are braking as well hard. So during the whole race duration, we are we are creating heat that we have to get rid of. And you know, especially the race car driver needs to get confidence into the car.
Sure.
So, and this he can only gain if the car always reacts as he expects the car to do, from the very first until the very last lap. So, and lap by lap, our car behaves in the same way, so you can push it to the limits. And that's the key for really having a race car, making lots of fun, fully electric.
Sounds great. Virus, when we talk about the challenges in oil development, which ones would you mention?
So the challenges in this new era or in this new field are, let me go back a little bit. So in traditional lubrication, we look back of up to 100 years of experience when we talk about internal combustion engines or lubrication of those or industrial lubricants. So we have a long experience list, and the customers, OEMs and the manufacturers also have requirements. They put in the spec sheet and they give it to us and they say, you have to deliver this, this and this. And so we work closely together and try to fulfill these specifications. When it comes to electric vehicles, everywhere where we have traditional lubrication requirements, we can look back on those experiences and work on those. But for the fields of electrification, now the lubricants being in touch with electrical systems or new compatibility and new materials, both of us, basically our customer and us as a supplier, we don't have so many, it's a blank sheet, I would say. It's not fully blank, but it's still open to develop or progress. So as we walk, we learn, and that's the challenging part. But on the other side, it's also a very exciting part, because it is key that we work together, as I said, hand in hand, to start from scratch and do not make compromises by approaching it the old way. So we have to fulfill this blank sheet. We don't have, for example, we didn't have any specific electrical testing in our lubricants portfolio. But now, as these requirements come in, we can tackle those. We can invent new tests and write these specs together in order to make these technologies work. So I think I summarized it pretty shortly, but I think the audience gets what I'm trying to say. So basically a green playing ground where we can start off developing new products and be innovative about it.
Fascinating. Ladies and gentlemen, I think you agree when I say Rüdiger just convinced us that this technology works so well for motorsports, for the GT4E performance. But what I'm interested in, and it's almost the last question, what about production car series? Is this also a future project?
So you may understand that I cannot share the product lineup with you today, so I'm not the one.
I'm so sorry.
So there's some CEO doing that stuff, so follow our press releases. But to be honest, motorsports has always a sense, and it's not playing a game only. So for sure, it's lots of fun, and the goosebumps. It's worth it to do so. But there's always some reason behind it. And when you look back into the Porsche history, you can always see that motorsports was something to prove new technologies, to create new technologies. And once it was ready or it made sense for a road car, then it translates to the road cars, for sure.
Virus, do you want to add something?
I think you summarized it very well, Rüdiger. Regardless of also Porsche being our customer, I think there are a lot of interesting products in the pipeline which will come on stream in the next few years, which we can be excited about, because the end consumer will benefit from it, and we're going to have fun with the products out there. So there's definitely something coming.
Great. Tobias?
And I would like to say, what we have done here, we have proven this concept actually works under extreme conditions. So we can go there where the heat is actually generated, where we need to get it away from the component in the vehicle. And I guess it makes us really a fit for the challenges of the future in the electric vehicle space. At the moment, as I said, we are starting with water glycol, with air cooling even, if you look into 5 years back. And one thing which really, I think, is applicable to the mass market. I mean, motorsports, as Rüdiger said, it's a fun game. You like to race it, but in the mass market, the question is what would be potential applications. And I would say, if we look at it, the thermal management, if you want to fast charge your vehicle, you really need to have good thermal control. And this is where our product can help. And we have, as Bruce and Rüdiger pointed out, a very close collaboration with Porsche, and we use this developments to think about the future, have new approaches, and develop the products together with a strong partner like Porsche, hardware engineers. And I think we will see this, as Bruce said, coming out in the future years.
Perfect closing words for our fireside chat. Thank you so much, gentlemen. And ladies and gentlemen, I am sure that there are some more questions that you have in your mind. I have a solution. Visit us at our booth. You can find the whole team of Mobile EV and also Rüdiger from Porsche in Hall B1 at booth C25. And there is also something that makes our heart beat faster. We have the 99X electric Porsche Tag Heuer Formula E car. Exclusively on our booth, you can take pictures and have a look, and for sure get all of the information about the new generation of EV fluids. Thank you very much. We hope you enjoyed the dive into the world of Mobile EV. We are prepared for your questions. Are we, gentlemen? Sure.
We are.
We are born ready. You know?
So follow us, see us at the booth at C25 in Hall B1, and we give back to Tobias, to the moderator. Thank you, and give it up for our gentlemen. Thanks for the deep dive.
Thank you.
Thank you.
Okay.